All right, today we're going to be looking at section 6.5, rational functions and rational inequalities. Instead of going to the textbook, I'm just going to start here with the lesson and give you a few notes, and then we'll start solving these. So there's three types of asymptotes that we're going to be talking about. So the first one is vertical asymptote. Vertical asymptote. Okay, these are values that make the denominator 0, so that's just the explanation. Values that make the denominator 0. So just for example, sometimes you might have to factor, but I'm just going to use this small example for, let's say, x plus 2. You only focus on the bottom for vertical asymptote, and let's say x plus 2. Take the denominator, set it equal to 0. When you solve, you would subtract 2 from both sides, and so that would give you x equals negative 2. So x equals negative 2 would be the equation of the vertical asymptote. So I just abbreviate VA. What that is that if you were to graph this function, there would be at -1, -2 here, an imaginary dotted line that the graph would not cross. And so since this is positive, I'm thinking it's going to be going up from left to right. So I believe this graph would be shaped in this form, something like this. Okay, the graph would not cross this line -2, so it's just an imaginary dotted line. We can show it when graphing, but if you use a calculator, you won't see that. So that is vertical asymptote. It's whatever makes the denominator 0. Now there are some instances where that term may divide out and become a whole, but we will discuss those when they appear. Okay, so vertical asymptote. The next one is horizontal asymptote. So horizontal asymptote, there are three scenarios. Okay, if you have, I'll just write the three scenarios out. Degree on top, or numerator, is greater than degree on bottom. Should be on bottom. So now I'll give you a little example. So the degree on top, let's just say we have an x cubed, and then on the bottom I have like maybe x plus 6. So this is a 3. This is understood to be a 1. The degree on top is greater than the bottom. If that is the case, no horizontal asymptote. So we have no HA. No horizontal asymptote if the degree on the top is greater than the degree on the bottom. Then we have degree on top is less than the degree on the bottom. Okay, so if that's the case, then your horizontal asymptote, so I'm just going to abbreviate with HA, is going to be the equation y equals 0. So if the degree on the top is smaller, and for example, let's just say we have just a 6, just like we just did before, and let's just say x squared minus 2. So this is understood to be a 0 degree. We don't even have a variable up here, and this is a second degree. So your biggest exponent on the bottom is larger than what you would have on the top. And so your horizontal asymptote is going to be 0 every time that is the case. And then there's one more scenario. If the degree on top is equal to the degree on the bottom. So for example, let's just say we got 3x squared minus 4, and let's say we just have a 5x squared plus 2. So when your degrees are equal, so a second power and a second power, then your horizontal asymptote is the ratio of those coefficients. So 3 over 5. So y equals, in this case, 3 over 5. But just in general, if I say ax squared, and then on the bottom I have a bx squared, then your horizontal asymptote would be y equals whatever the ratio of a to b is. It could be a over b. And this could be any number. It could be a whole number. It could be a fraction, just like we just had here, or it could be something in between. So whole number, fraction, negative, positive. Any ratio could appear. So we have no horizontal asymptote if the top is greater. If the bottom is greater, then we have 0. And then if they're equal, then you have the ratio. So that's with horizontal asymptote. You have 3 scenarios. And then there's one more. It is a slant asymptote. We need an E on that slant asymptote. So this one, if degree on top is exactly 1 more than degree on bottom. So for example, if I had, say, x squared minus 2x plus 4, just for example, and then that was divided by x plus 5, just making up. So the degree on top is 2, the degree on bottom is 1. If the difference from degree on top and bottom is exactly 1 difference, then you will have a slant asymptote. And I'll use this as an example. The way you figure your slant asymptote is you're going to do long division. So I'm going to put this x plus 5 out here. And then I'm going to have x squared minus 2x plus 4. And we're going to do long division. So I want these to match. I have 1x, I need 2, so I'm just missing 1x. The numbers are the same. X times x will give me x squared. X times 5 will give me 5x. And then you subtract, so this becomes negative. This becomes negative. And then that will cancel out to 0. This will give me a negative 7x. Bring down your plus 4. And then you repeat. And so I have this x and I have a negative 7. To get those to be the same, I just have to multiply by a negative 7. All right. and then negative 7 times x gives me a negative 7x. Negative 7 times 5 will give me a negative 35. Then you subtract or change the sign. That becomes plus. That becomes plus. And then at this point, you're done. This will go to 0. And then this will give us a positive 39. All right, so that's your remainder. Say remain. Okay, the remainder does not matter. This is what we're focused on right here. X minus 7. So once you finish, you'll have a linear equation. Your slant asymptote, in this case, SA, which I'm going to abbreviate, is going to be the equation y equals x minus 7. And that on your graph is just going to be, again, imaginary slant line that the graph does not cross. So it would be, if I go down 7, 1, 2, 3, 4, 5, 6, 7, and then up one, right one, up one, right one. So it'd be like a dotted line or imaginary line that the graph would not cross at a slant. And then with your horizontal asymptotes, there will be horizontal lines at y equal whatever that number is. So these are all the different types of asymptotes we get. There are vertical, okay, it'll be a vertical line, and it's going to be x equals some number. You have horizontal, okay, which will be a dotted horizontal line. And I didn't draw any of those, but let me draw one down here. Let's just say, for example, this 3/5. So say this is 1 3/5 will be somewhere almost halfway between. There'll be the dotted line right here that the graph would not cross with the horizontal. So some imaginary dotted line that you won't cross depending on the scenario of horizontal. So you got 3 of them. Top is bigger, the bottom is bigger, and they're equal. And then you have the slant asymptote, when the top is exactly 1 more than the bottom, and you have to do long division to figure that one out. So these are the different types of asymptotes that we're going to be solving for. And with that, we're going to stop and we'll start our practice examples.